So these are the calculations. I'm going to use this guy here. So 0, v, the absolute value of v is the square root of 0 squared plus 2 times negative 9.81 times negative 6.4. So square root of and that's 11,2057, right? And I make it negative because it's got to be negative. No, it's good. It's good. All right. And then here I'm going to use this guy. S is ut plus 1 half at squared. So t is 2 times s over a square root. Right? So square root of 2 times 6.4 negative divided by 9.81 negative. I'm going to store this guy in my variable t because I want to use it. And then I'm going to store that velocity. I'm going to store that in v. There we go. And then this castles across. And now I can use s equals ut to find this guy. So 9.2 times 1.14. So times 9.2. So check your answers, boys and girls. Check your answers that you got 1.14 seconds, didn't you? That's the time he's in the air. 10.5 meters is how far out he hits the ground or the water or whatever. Yeah? Okay. The final vertical velocity of impact is negative 11.2. Okay. It's important that it's negative. This formula doesn't give you negative, but you got to slap it on there because it's going down, right? And then the final thing, part E, is we got to draw a picture of his velocity of impact. That's this, right? So in vector component notation, it would be 9.2 meters per second, x direction plus negative 11 meters per second, y direction. Yeah? But in angle magnitude notation, we have to draw a picture, 9.2. It helps to make your 11.2057 or whatever it is, right? To make that longer than this. And then the magnitude of this is square root of 9.2 squared plus 11.2057 squared, which I've stored this number in my variable v, so that's what I'm going to use. 9.2 squared plus alpha v squared. And I get, somewhat surprisingly, 9.27. Okay, this is wrong. Second entry. Oh, there we go. Yeah, that's the wrong thing. Okay. The square root of 2 times 6.4 times 9.81. There we go. Now we're in business. Okay. Hold on. This is 14.498 or something like that. Or 14.5 meters per second. Right? And then this angle here is going to be inverse tan of 11.2 over 9.2. That angle is definitely not adorable, correct? It doesn't look adorable, and it should not be adorable when I do it. Shouldn't be less than 45 degrees, right? So I'm going to go alpha v divided by 9.2. 11.2. 50.61. Are we good so far? And then what is the speed? If you had to say, well, how fast he was going when he hit, what would you say his speed was? It's the magnitude. His speed is this, right? Yeah, speed of 14.5 meters per second at an angle of 50.61 degrees below horizontal. Yeah? Yeah, But at that instant, that's his velocity, right? So he's coming off this cliff. Here's the cliff, right? He's following some trajectory, right, where he's got that velocity at that instant.